We are now recording.
Awesome, awesome. Hi, everybody. Welcome to a building query call that I'm hoping we can get super into the weeds for a little bit and cover something that I think is important, mainly to get some concepts on the table and sort of think through some of the stuff we've been working on. So if everyone's okay with that, today's going to be pretty technical, but I'm going to try and give a little demo of like an RFC that I'm hoping I've been working on for like 3 weeks. It's been a serious undertaking, and this surrounds Jonathan, your question around how do I query. So this notion of being able to ask questions of your collection of data sets and reshape the data that you need. This also gets to the question that Rob, you've been asking for a long time, where you said it was kind of a non-starter if I can't join data together. So like have two data sets and like have them connect on an ID type thing. Definitely like an advanced use case of what we're going to talk about today. But there's been a number of like underlying technical problems and questions that we sort of had to deal with. Okay, what did you say, Rob? I can see this. I don't think I said it was a non-starter. Good point. Whenever you say I would really like to have this thing and I think it's technically legitimate, I'm like, okay, it's not that it's a non-starter, but for me it's a non-starter. I can't. But anyways, yes, exactly. I'd take your feelings and add a couple of multipliers because yeah, it matters to me. So yeah, today I'm gonna, if you don't mind, I just want to quickly sort of share my screen and talk through the high level of like what's going on with some of these with this like problem set and how I think a couple of things that don't seem like they're related on the face of it are actually related. And then I want to talk through sort of like the real danger of like scope creep with things like filter syntax and a number of other things. So please feel free to punch questions in the chat. I literally threw some slides together like 2 seconds ago. So we're going to see if this is any way useful. Let's see if this works. Is everyone seeing, and if I move this from that screen out, or okay, hopefully you're seeing filters and linked data. I probably should have just shared my whole screen. Actually, give me 1 second. I'm going to do that. Stop sharing. Share desktop 1. Oh, wow, it like labels them now. That's nice. Okay. Do you now see like this thing and like a not secure thing, ton of stuff? There's Discord. Cool. All right, filters and linked data. So I think there are two problems here that are connected that don't seem like they're connected, and it's really hard. Basically, the problem. Okay, what do we want first and foremost? Like starting with the benefits that we're interested in is like filters. The high level sort of point of a filter is to be able to shape data as you need it. And so like just talking through some concrete examples of that, like an everyday thing that we do all the time. It's like query get. And we have this thing right now called query. On the command line, I can type, I should just like punch this into a text editor. I can type query, sorry, 1 second, query get body. And that will fetch the body of a data set, right? And so the output of that will be some large thing. And we currently have these like sort of hacky things that only work on the body, where we can do like page size is 20, and then I'll just give you 20 rows of the data set, quote unquote. Other classic examples that we have are, before we even get to filters, but these are this body thing is kind of a filter-like thing, because what we're saying is if we were just to do query get, and then the name, actually I should make this fully complete. This is query get the data set name. If I were to do just this command, I would get the entire data set. And then I can filter down, I can sort of quote unquote filter by doing query get body, which kind of works. That will just give me the body. So that's saying and what I'm actually doing there is I'm shaping the data set return value. And to Jonathan's question, we want to be able to sort of like ask other kinds of questions. The one that I'm really excited about is like query search. You can do like currently you can just do like query search, population. And this will give you a list of data sets that have population in their index. And wouldn't it be neat if we could sort of, so the return value of this is actually under the hood an array of data sets, right? So there's data set, 0 and data set 1 in there. And if we would get some really nice properties if I could do query search population filter body, and that would just give me the body results, right? And so that's just combining this concept of a body and and this sort of, but what I'm secretly saying here is I would like you to sort of aggregate over, because search returns an array of stuff. I'd like you to aggregate over all of those and give me all of those things, and then allow me to shape that series of returns so that I'm now getting just the bodies. Or if I use syntax like this, I could say, just give me the first 5 rows of the body. And so that would say, cool, I just want to preview, right? And then I can sort of like get a little fancier. You'll notice that I'm typing you might notice I'm taking JQ syntax for this. Today, I don't really want to talk about like the actual syntax that we use for querying so much. I have lots of reasons why. I think JQ is actually the only viable querying syntax for this. I've looked at everything I can, and aside from like, I really wanted to choose something that already existed. We'll talk, hopefully we can sort of set that aside for other, but if other stuff question, we can totally go off from the weeds for a bit. Anyways, so currently we can do query get, well, this is broken right now, but we fixed it in a recent PR that will be released, but I can do query get me dataset 1, me dataset 2, and this will also return an array of results, right? And so now I can do, and so wouldn't it be nice if I could also, and I can also type body, and that will do exactly what we want. But we want to be able to get more specific, right? We want to be able to do like meta.title, which is saying, just give me the title of these 2 data sets type stuff. Neat. So far, does everyone follow? It's just basically like laying the groundwork. Like we want to be able to filter and reshape the data that we want as we need it. We should also be able to do more complicated stuff than this. We should be able to, like as an example, create an object that is like title. And then I should also be able to do like commits. And this should, or like created. And this should be dot commit dot timestamp. And so basically now I'm generating a new object for each return value. And so the return value of this would be an array of objects that's like, you know, title A or whatever, and created. This would be a timestamp. I don't know how to type Unix timestamps off the top of my head, but it would be something like T 2019, whatever. It would be long. Computers do this for me, so I don't know how to do it, but you get the idea. And there are 2 of these, which is cool. Cool. So we have that kind of, that's in the works, and we're working on this like way to sort of iterate through a lot of this stuff. But what I want to talk about today is just some of the underlying sort of stuff that came out while working on this. And really quickly, you run into, when you talk about filters and you talk about filtering data and you want to be able to have it work quickly, with this body example, we're talking to something that is potentially massive, right? That body file is potentially a really, really, really large thing. And we have an opportunity when a user gives us something like this, like a querying syntax, because they're telling us what they want. And by telling us what they want, they're actually telling us what they don't want at the same time. Because this filter statement contains no information that is talking to the body of a data set. And so that body of that data set should never be loaded, and that should never be traversed to, that should never be talked to. Query should not open up that body file. And you shouldn't even, ideally, you shouldn't even need that body file to be able to sort of resolve this type of query. And this becomes like more and more important as you're dealing with more and more data, right? This search answer, we have lots and lots of caching mechanisms in the background for our registry stuff that is going to make this search fast and work really well, but certain pieces of data are going to be missing from it. And so it would be really nice if we could just return an error here if you asked for the 1,000 rows of a data set and we aren't certain, like we're not serving that to you. So we want to say, hey, you're not actually not able to do this. You can only ask this question. It's like the first 100 rows. And so now with the filtering syntax coming into play, we now have like a few more opportunities to sort of deal with what kind of links that we resolved and what kind of data that we load as we're working on it. And this is where we sort of get into some work that we've done a long time ago that I'm going to quickly pull up, called QFS. And this sounds like some big, massive project. It's really not. And so we're going to go to a completely different neck of the woods for a second and talk about QFS, which for us stands for the query file system. The QFS is not an IPFS replacement. It is not anything fancy. This shook out of us needing to sort of make something that was able to deal with multiple types of things. And so I've got this slide here. It's like a multiplexing file reader is the big thing that it does. And so with QFS, we have a way of dealing with the following types of things. If we see this, epa.gov/data.json, we understand that because this string starts with https:// this is a link to a URL, and we should use an HTTP resolver to perform a GET request to fetch this file, right? We also know that if I see this path to local file.json, I know that because this starts with a dot and a slash, I can generally assume that this is just a link to the local file system. And because we're weird, if we see this, we know what to do here as well, right? Because we see this /IPFS prefix, and we've intentionally been providing this everywhere, we know that we need to load this from IPFS. And if we don't have an IPFS resolver or something that is able to sort of fetch IPFS links for us, then we can't actually traverse through this link. And so the QFS project, it just sort of evolved out of us trying to wrap around IPFS to do the things that we wanted. But over time, we came to realize that when we started to do our file system implementation, and even long before that, we needed some way to sort of deal with these lots and lots of different sort of types of links to data, right? And so how are these two things connected? Well, if you look under the hood at any given data set, any query data set, the actual like meat of what you're getting like under the hood is a file called dataset.json that is actually composed of a bunch of links. So if you look at body, as it's stored on IPFS, this is actually just a path called IPFS QM blah, 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 blah. And this is the immutable canonical version of a data set. And so what our code base has currently been doing is whenever we see body, we actually traverse through it. But what I sort of wanted to come up to today, and hopefully this has not been too long-winded, but we're already doing this in a very manual way. But if we want to get to a bunch of like new features, like being able to load the right thing at the right time, and the thing that we've been talking about a bunch internally is like this notion of being able to have attachments that are just variable files. We need to sort of start to get smarter about these links, and we need to start to get smarter about the way defining a mechanism for knowing when to do the right thing, which is like in other words, how to resolve a link at the right time. And so this kind of gets, the reason I wanted to talk about this today is like this is sort of like at this really weird intersection where as we're working on querying syntax, we started to realize that what we actually need is a pretty robust linked data platform to be able to do this properly. And I have yet to see a linked data platform that I don't think is trash. And so this is a really hard to deal with problem because like you have to sort of come up with a really clear and robust definition of what a link is, how a link gets resolved. And you have to be very careful. I think a lot of projects that I've seen in this space have gone on to do really, really sophisticated stuff, but they become more and more idiosyncratic as they go on. So like I'm looking at like the JSON LD project and some others, like there's just like really, really, like you can define a schema for how a JSON LD thing should load, and it'll explain a lot of stuff, and it's very specific and idiosyncratic, and it's really hard to do properly. And it's really hard to write in a way that works. We've also I've seen like the IPLD project and like the challenges that they've had with getting linked data to work properly across a number of sort of like styles of resolvers and stuff. I really want to just quickly show how these two things play together, and this will be the last bit of this conversation. And so this is like purely, I just want to show the like source code behind this, but it's a fairly simple, yeah, to sort of drive the point home that I think these two quite closely connected, and that you can't properly write a filtering syntax without, in this context, without dealing with the idea of a link and when to resolve a link. So I'm going to really quickly just show, this is like, hopefully this is large enough to see properly, but if we look on my file system here, I have a file called data.json, and if we get bigger, more, good. Oh my gosh. Oh, okay, that was terrifying. My screen just went really weird. Okay, so if I cat data.json, it's a very simple file, right? This is an object, it's a JSON file, it's an object, and that contains all these entries, but it has this thing called small.json. And then if we quickly just cat small.json, it's pretty small. It's got an array of a date. Cool. So This is just a proof of concept. I call this QFT for like query filter, but mainly because I didn't have time to think about it. But if I do query.data.json and I feed it that filter thing that I was just talking about, this dot just means give me, this is like the identity filter, which means like don't actually filter anything. But if I just do, like if I just select A, this will just give me the A. And then if I do just select, the first two things of A, this is just going to give me the first two things of A. But if I do, this is where I think if we do query data.json and then I do, I got to do this again one more time to get this back on the screen. Cool. And then we go to K, I'm just going to get small.json. But if I add this actually is going to go open that file, use the QFS muxing file system to say, I think this is a link and I think you're trying to diverse into a link. And so I've added this syntax, which is the iterator syntax from JQ. And so this actually isn't breaking anything from JQ land, but we're overloading this to say, if this is a link, if you try to traverse into this link, I'm going to resolve it for you. And if I try to resolve it for you, I now sort of have this. Can I do date one? Let's see if that works. Oh, that even works. Cool. And so basically what this is when I just seek to K, that link is never loaded. That's just a string and nothing is ever touched. But the second I try to traverse into K, or the second I try to load a body, I'm now talking to a link, and the filter syntax knows that it needs to kick into resolution land before it can actually do stuff. And so basically, we're saying if you try to do any complex object-y or fancy type seeking into what it is effectively a string, it's going to say, we need to start have a look at this and try to understand what's going on. What this will mean for us in query, if we have something like this, is the filtering syntax that allows us to say what to specify, what to resolve and when to resolve it. And we have years of work we can do around making that faster and smarter all the time, where we can make things that just don't ever load blocks that aren't needed, or we can say don't ever fetch things that aren't required, or being able to sort of cache certain filters and sort of say, cool, this is going to be a way to resolve this much faster because we know we're dealing with immutable data. But also on our work on the file system side of things, by taking a definition of a link that is based on our QFS multiplexing version, we can define stuff like this with this example that I just showed. That is just generic to data, right? Or generic to JSON heuristics. And so this is just a local reference. We don't have to do anything special to make this other than sort of keep our definition of what a link is and how to resolve a link very sort of carefully pruned. And so things that start with HTTP : / those are URLs. And that's the heuristic for defining the thing, URL thing. And there's lots and lots and lots of weird and difficult idiosyncrasies to this, but you get some really nice primitives out of this, where you can define data sets, just grab data from all over the internet and then smash it through and create an immutable version. And using that same syntax on the other side for, I'm going to return to you a resource that is going to be loaded over HTTP, and then another resource is going to be loaded over IPFS, and everything will just kind of work. Anyways, so the reason I wanted to bring this up is this is a ton of thinking, and I think that I've been trying really hard actually for the last couple of weeks to make something that is as small a scope as possible, and that introduces as few new things as possible. But to do that, I think you have to have a fairly technical conversation around what is a link. So I just wanted to surface that here for conversation.
First question. I guess, this means you can't index into a string, right? Which is probably a good thing that we don't want to support that. That clearly must be the consequence.
Totally didn't think about that.
It's not obvious what indexing into a string means, even because, code points versus bytes, encoding, all that stuff, right? If we did it unspecified and just say you can't deconstruct a string using the syntax, maybe that's the right thing.
Yeah, we maybe introduce something special, or it could be we need something. We might need a keyword for resolve this link,
Well, this is kind of funny. Jonathan indirectly discovered this while trying to convert a string into a list in Starlark. Strings in Starlark can't be iterated because of this ambiguity. You have to, it has different methods for, turn this into a byte iterator versus turn this into a code point iterator. So, maybe we kind of steal that concept if we need it. Wait, other question is, when are we going to support BitTorrent and magnet links? Because we can totally do that too, right?
Yeah, like next week, right? And obviously, like, yeah, we'll get that in there like the next day. But
Git also. Yeah.
Rob, what's up?
Only if Dustin's done with question. Okay. This seems like the obvious question, but if something's a link, it seems like there's an important question there as to what does that mean with regard to immutability and hashing and whatnot. Like if I add a data set with some links, how do we know which ones are links that should be resolved and somehow hashed so that what's saved in query is an actual immutable thing that references the thing that I was referencing at the time? Or like, do I even necessarily want to do that depending on what I'm linking? Like, it seems like there's a lot of ambiguity there.
Totally. And I think it's important. This is you hit on a really nice theme, which to me is the separation between the sort of technical underpinnings and then the application concern, right? And to me, the question that you've asked is very, we can answer with an application level concern, because that's like a query, what is an immutable data set? And for us, I think that is where all of the components of a data set are immutable, meaning you could use a URL link as input, but if you ran query save and you said, cool, and the body is going to be, and you just smashed a URL string in there. On the way in, it would say, I need to resolve this link and make it immutable in order for this to count as a query data set, right? Now, if you said the meta home URL is an HTTP link, we consider that sort of a business logic concern, and we say, no, it's fine. That's a link to a URL on the internet. You don't need to make that immutable. If you want to, though, you could type /IPFS/a thing, and under the hood, query would know how to resolve that for you. And so what I'm trying to say in as clear as terms of possible is like, there will be certain things that must be immutable for it to count as a dataset version. And I think that's effectively the body, all top level components of a dataset, body, meta, schema, anything you would need to be able to play back that data as a version. But it also gives us, by having like a more loose underpinning at the lower level, we can use a lot of this stuff as input immediately. And we can also sort of like flex those rules as we start to realize like, oh shoot, no, we actually really want to be able to do this for some reason we don't understand today.
That all makes sense. I guess I was thinking, my brain was fully in the context of like, this is in a like property of an object that is in the data. Because it seems to me like there's a situation where like, there's just a URL in there and that's fine. Or there's a situation in there where I guess my head's here because you were talking about this at the beginning about linking together this idea of like, how am I doing joins? This is really effectively a foreign key, as it were, right? And like, at what point does a particular cell need to be interpreted as like something that what query records is some kind of immutable link? Does it is that a question of like how I formatted the link, or like, is this not even a place we've started thinking about yet?
Yeah, actually, relatedly, is the schema going to be used to solve parts of this, or we have a schema? Is that the answer there, or is it something we could be a little more aggressive on?
Yeah, those are both really good questions. On the body side of things, I think it should be possible to do both. Exactly as you said, Rob, I think the foreign key concept can be very powerful. The idea that I have a list of URLs as like data set values, I think is useful. And I say, look, these are just external, and what's valuable here is the list. But then there's also this concept of like, I want to be able to embed the actual contents of those URLs. And I think we've been calling those attachments. And I think the idea there would be in a linked file system thing, you would make a folder called attachments. And you would make a data set that references those attachments as local file paths. And we could make a heuristic that says any locally referenced files in the body should be resolved to hashes, but labeled as such, so that it still shows up in the data as a thing, but then we sort of have a mechanism for embedding the actual links inside of the DAG that is created, and keep that on IPFS under this like attachments folder as like a starting point. theory being, you should be able to, basically what I'm trying to say is you should be able to do both. We got to get the heuristics for that. Yeah, go ahead, Rob.
So this isn't aiming to be a mechanism through which, I don't know why this is in my head, but like, let's say that I have a whole bunch of different data sets that are like the Billboard Top 100 for year X. And then I want to make a data set that's like all Billboard Top 100 years. And those are links to each of those data sets. Or like links even to particular cells in that data set, like I'm building up like the meta set somehow. This is like not an avenue to get there.
I think it is. Yeah, but that's, and the way you would do that would be a immutable link, so like a /IPFS, or we'd have some sort of, we'd have a schema level thing that says this is a data set reference, and then you would do a named data set reference. We would have to do magic under the hood and record what versions that you're referring to, so that we have an immutable record of an immutable record. But that, we didn't talk about this today, but when you resolve a link to a data set, you get back something slightly different than what you would get normally. It'll be a thing that contains more links, but it's not actually slightly different. It's the same, but we need to introduce one new concept for like body iteration that Dustin actually alluded to earlier with the notion of adding an iterator type into this. But yeah, I totally think you could do that with this. And I think that you would have the nice flexibility of having that, those data sets may not be embedded, but the immutable references to them would be, which is like a nice property, I think, because that data set itself is quite small, and it allows you to sort of track stuff. There's some more stuff that we can do there that I think we can like talk about in the future. So, part of which is like conceiving of the filters as a transformation syntax. So you can actually say, search for this, apply this filter, and save the output as a data set. And then I can now rerun that whenever I want, tracking versions, which I think would be an interesting, that's really getting close to like what Jonathan was talking about, like query and query, but making data sets out of the query results. And so you could be, it's just turtles all the way down. This gets really complicated, but I want to briefly get to what Dustin was saying about schemas, which is the other motivation for this, because part of what we're seeing in schemas is like, we've had this long-awaited sort of like avenue of research of being able to say, like, I think GeoJSON is a classic example. The actual GeoJSON sort of like schema, if you write it out as JSON schema, is massive, right? And you have like the definition, and there are components of that definition that you would really want to be able to reuse, right? A classic example is like a point, which is a latitude and a longitude, and the field is named lat, and the thing is named long, and it should start. I can't quote the number, but Chris is going to know the number off the top of his head at like -44 or whatever, and go not go higher than some other figure. And that like tiny sort of atom of a schema, if we could link to that instead, we could build up much richer descriptions of schemas and say, and so I could just type GeoJSON and I would get a thing that actually contains a number of links to other elements of schemas. And the JSON schema spec already has all of this built in. And so we're just codifying how it works in our system, which they use the notion of a JSON pointer, which is a IETF spec. But that would allow us to do much, much, much smarter things. And it would allow us to connect together data sets that are actually talking about the same thing by commonly referencing these immutable atoms. So if we took that definition of a point, saved that to IPFS and said, this JSON schema, this GeoJSON's definition of a point, and it is shared with some data set that isn't participating in the whole JSON schema spec, so they're not entirely, or GeoJSON, have I been saying Geo the whole time? So the GeoJSON spec defines a point, we take that point and we save it as its own little unit, and then somebody writing census code, and they're not fully participating in GeoJSON, but they do have like the definition of a point. If we share those, we can now we know that these two things are like immutably and causally linked, which is a very exciting sort of like mechanism for traversing across schemas and doing schema intersection work, where we can say, no, these two schemas actually do talk about the same thing. Not like kind of same things, but like same thing. Composing those schemas is really complicated. And so this would have to be coupled with a editor that looks this stuff up for you and builds this stuff up for you and suggests to you when you should really just use the definition of a point. This is really, really, really long-term thinking. And so what we're really trying to do right now is just land down the definition of a link and say, cool, if we can combine this filters concept with this links concept, and this actually can fly, then we have the ingredients we need to sort of get to those things. But first, we just need to make sure that this sort of works. So Dustin, that was, I think, the longest possible answer to your question. Is that remotely getting anywhere?
Yeah, that wasn't totally what I was asking, but that's also a related part of it. Like, the thing I was more wondering is, like, you know, on input, we can't assume that a URL, for example, Jonathan was also asking about this in chat. We can't just assume a URL is a link as opposed to a vanilla string. But, you know, schemas can be a way to specify that certain columns in the data set body or whatever these actually are links if we want. I don't know if we actually need that kind of functionality. Like, there's an interesting question around, you know, where is a link on input? Like, where does that matter versus the filter syntax is more talking about the output of data sets, right? Things aren't necessarily immutable anymore, as Rob was getting at. Like, there's kind of different use cases that are handled by all this tech. There's a lot going on here, I guess.
Yeah, totally. It's a total rat's nest, and it's been really, I think the biggest challenge here has been making sure that we don't go and reinvent the entire universe, right? And so I think that I'm hoping that the virtue that is coming through is like not coming up with some new definition of what a link is. It's just a string, and if we can resolve it, we can resolve it.
Right, and also the important part is that the original motivation for this is, like, we already are doing some of this on save. Like, when we ingest data, we're already doing things like turning the body into a linked file. And as you were saying right at the beginning of this meeting, a lot of that is just like unrolled abstractions that are in our code base that could be solved by like putting in just better primitives that take care of all that stuff in one place. So yeah, like the state of the world already, you know, like contains some of this stuff. So if we don't have a good way to talk about it.
Yeah, totally. And it's, I think the QFS stuff has come through as like really helpful on the file system linking stuff, where you can actually just say, hey, this is that. And so like the body of a data set is a file called USGS earthquakes.csv. And that is just a local link, and that we've been actually resolving that quite nicely already. And it has this nice extra property of when we use that muxing QFS, if you type in the body of a data set is http://epa.gov/data.json, it just knows, oh, I'm going to try and do a GET request to this. And to me, that's a really nice property. And then if you try to say the body of a data set is, hello, my name is Greg, that's a string that we don't know what to do with because it doesn't match some common heuristics. And I think the real work here is babysitting those heuristics, right? /IPFS / and then like dat : / you know, what do we do when we see Postgres : / That's like a whole nother like, oh, let's not do that. But one day.
What about C : /
// yeah. Yeah. Anyways, this was a bit of a technical like march through the woods. I'm not seeing anybody being like, this is a horrible idea, don't do this. Oh, but Jonathan, you have something in the chat. Wouldn't check locally, like the same folder. And see, that's the biggest question. I think maybe, yeah, if there was a file named hello, my name is Greg. Yeah, I think we would totally check for a file named hello, my name is Greg. Particularly, and this is where the business logic thing comes back in. If you made a body key in a data set definition, and you said the value is hello, my name is Greg, yeah, we're going to check for a file. But yeah, I don't think it's too much of a security problem. Greg seems all right. I don't know, I'm not too worried about him quite yet. Oh, yes, that's a good one. That's a good security problem. Maybe we should refuse to resolve things that we don't have permission to access as the current user. We could do fun stuff like that. No, all right.
Absolute facts are a good start.
Yeah, off the top of my head, security answers is probably not the best way to write our spec around how to keep query safe. But anyways, I think the other thing I just wanted to point out is that I think this is a really exciting sort of like set of body of research, like being able to sort of just say, if you combine this with some stuff that we'll be writing and I'll be adding to the RFC, like around iterators, where it's like, hey, consume this. And iterator is just like, a stream of structured data. And so like, if you have an object, then it'll give you each successive thing on every call, which the JQ filter syntax actually does under the hood. Converts everything into a stream of tokens. Has like a really nice set of properties. But I think we can get away with a lot of this without introducing, instead of like saying like we need to reinvent stuff, we can just build on what exists. Strings are links, and JQ is an amazing filter syntax that I don't think we have to do too much. Ideally, we could just stay all the way inside of the JQ stuff. But yeah, I think we have like, this represents some like really exciting refactoring stuff for our code base. We have to do some really funky stuff when we load a code base right now. We have this method that all of us really don't like called open dataset files, which like actually just preps file descriptors for like transform scripts and body file data, and then often just like close it without ever using it. This is just like a silly OS hit that should never happen. But you should also be able, and then the other thing that's super frustrating is you can't just say like, give me the first 5 rows very easily. And that to me is a real sort of loss on the filter syntax side of things. So ideally by landing all these at once, you get best of lots of things. I was supposed to be doing all of this over the last week, and then we got really sidetracked doing Query Cloud stuff. So I've been working on this like proof of concept in the background and mainly just getting the thinking right. The other thing that we had here, and I would like to sort of like thank Dustin for keeping us from doing, I almost was like, we need to define like a string type for query. And it was like, no, this all needs to like, and this is in the Go side of things. But he kept us from becoming a platform, which I was very happy about. So we're doing all of this on like native Go types with like a nice compact set, which will mean that the code that we write will be far more usable outside of queries walls. Anyways, anybody have any questions on any of this? I know this is a bit redacted and protected and weird, but as a builder, I kind of want to allow our building query calls to get more technical, so that if others want to sort of jump in on this stuff or weigh in on some of the concepts that we're sort of working on, I think it's really important to make space for deep dives. But any questions? Anything? That's just a lot. Sorry.
I mean, this is wonderful foundational work. We did an RFC, and then, I mean, like, assuming everyone was all gung-ho on this on an RFC, when do you see this actually happening if we decide that it's something we want?
I think, to be honest, I think this is going to take at least the end of September to like really truly flesh out properly. Getting everything right takes time. And I think the thing that needs to go before this is actually the shared histories of data sets. We've run into this thing that we'll talk about in 2 weeks around when you create 5 versions of a data set. Currently, the only way to traverse to version 0 is by having all of the data sets that connect down to it. So we need to build this index. And that index stuff really closely ties to the benefit of like the network tab in GitHub, where you can see all of the forks of a repository. So we need to build a thing that does stuff like that, where you can combine 2 histories, and that's also a source of encryption. I think we need to do that first, because the benefit of that is when you hit publish on a data set, you can just see all the versions of a data set that you don't have. And I think that's more important personally than, we should take a vote on this, but I think that's more important than being able to filter stuff for now. Just because if I make 15 versions of data set and each of those versions is 200 megabytes and I only publish the latest one, I think everybody else needs to know that there are these 14 other versions that aren't published or that you haven't downloaded, but they exist. And so I think those are the 2 competing features right now. And the question is, which is more important? And we're going to land 1 in September. Thoughts? That one, Chris, do you vote for? Rob, which do you vote for?
Well, I have clarifying questions, I guess. So can you publish a version with 5 versions in between it and the previous one, and those are just publicly inaccessible somehow?
It's our present state of the world. Yeah, it's awful because we don't have this notion of an index. Go ahead.
So
Okay.
the way that would work is that they're shared on IPFS. It's just they're not guaranteed to be available, right? So like if your node is still running an IPFS game and like someone could like get those blocks eventually over time at some point. But when you publish, we only guarantee that one is actually pushed live. The newest version is pushed live.
So if I have a data set and I publish version 1 of it and I publish version 5 of it, at the time that I publish version 5 is sort of guaranteed to be available because you're pinning it. Are you also still pinning version 1?
We are, yeah.
Okay,
now the problem is you can't traverse to version 1 anymore.
Right, but you're never necessarily going to pin 2, 3, and 4.
Yeah, so presently it just pushes all the versions if it can. It starts with the first and it's considered successful if it gets the first. But that's going to be a real problem as we go down the line. And we also just data is different from code. Data sets get really big, and I think it's a very meaningful use case to have just the latest version of something and know the history. So know that there are 35 commits and I have the title of each commit and the date stamp of each commit, but I don't actually have the commits themselves. To me, I think that's a really important thing that it would power the history tab in Query Cloud. It would be the thing that would allow you to see these other versions that exist. And if you want to go back 25 and just fetch the Genesis version, that's fine. But yeah, presently, we don't have a mechanism for doing that. And this is what Git's reflog does. And so it keeps all of this. It's not exactly what Git's reflog does, but it's kind of what a branch history is for Git. We completely centralize Query's repo stuff, which works great until you start to collaborate. And then you start to push stuff around, and then you need some sort of index tool. And then ideally, you'd be able to use those indexes to understand the whole universe of data sets that's available. And so I could say, hey, I can combine 5 indexes, and now I can see the history of 5 data sets in the same sort of space, and if any elements of those intersect. I should be specific about the elements, if any commits of those intersect. So if you forked off of my data set, we should see that common history when we combine the 2 reflogs.
That makes sense. I guess I'm just surprised because I hadn't thought about the problem that publishing a data set doesn't necessarily mean that the whole history is actually accessible at any given point in time.
Yeah, we managed to get around it most of the time because most data sets are actually, in practice, many data sets are quite small. Like you can really put 40,000 rows or something into CSV, and that IPFS handles that quite easily. And so moving 100 megabytes of data is not the end of the world, and so it's not that big a deal. But I think we'll sort of run into this pretty quickly. And just having query not fall apart when you don't have a version is, I think, a really important property. Yeah, so we're going to answer Chris's question again, the most long-winded answer possible, but we're going to ship that first and get that right, do that right, get a spec up for it. I've been doing a bunch of research around that and how we can actually turn those into CRDTs, which makes them conflict-free, which is a really nice property that just comes out of the side of this. And that will make for better collaboration when you don't have a centralized source. But yeah, I want to get that out first. I want to talk more about that in 2 weeks and really show the sort of result of research there. But I think we'll do all this filter stuff after. But the CRDT stuff depends on the link stuff. And so I really wanted to talk about the link stuff today, just to see what everybody gets some thoughts from everyone on that. Hopefully that all makes sense. Cool, I'm seeing lots of nods. Lots to think about. We'll get an RFC up and running that we can happily debate. And ideally, I'll ping everybody here if they have any questions. But otherwise, thank you so much for listening to me blather on for 25 minutes. Does anybody have any closing thoughts? Otherwise, I think we can all have a lovely extra 15 minutes on the hour. Awesome. Okay, then I think we'll call it there. Thanks so much, everybody. And looking forward to talking soon, Cub Scouts.
See y'all.